boys and girls, welcome to our very first video lesson, our lesson on Chapter 4, Section 1, our lesson on radian measure. Please have your note packet open to the appropriate note page and be taking notes as you're watching your video. I ask you to stop and do a problem stop tape, and then you can do the problem and pick things up once again. Okay, let's talk about radians. A radian is a unit for measuring angles, much like degrees, which you already know about. But what's beautiful about radians is that if the measure of the central angle theta, so if this is theta right here, if theta is equal to 1 radian, therefore now our radius will always equal the arc length s. So if this angle is 1 and the radius, let's say, were 3, that means that the arc length is going to be 3. If the measure was 1 radian, and the arc length was 17, then this, the radius were 17, then this arc length would also be 17. Okay? So in other words, our r, if theta is 1, our r is always going to equal our s, where r is the radius and s is the arc length. That is when our theta is 1. Okay? This brings us to a very nice formula. The arc length formula says s, arc length, is equal to the radius times theta, when theta is measured in radians. Okay? So because of full circle, so if I take a circle, its arc length the whole way around is 1 circumference of the circle. So therefore, this angle, if I measure this angle all the way around, is going to be 360 degrees, but it's also 2 pi radians, because you know that the circumference of a circle is 2 pi r. So in other words, arc length, circumference, is equal to the radius times the angle length, which in this case is 2 pi. So 2 pi is equal to 360. 1 pi is equal to 180. When you are measuring an angle in degrees, we're going to put the little symbol there, the degree symbol, the little circle. And angles measured in radians will just be the number without a label, which sometimes could be confusing. So, converting degrees to radians and radians to degrees, we're going to multiply by pi over 180, or 180 over pi, and that's because 180 degrees is equal to 1 pi in terms of radians, right? And we don't write that unit. So 40 degrees is going to equal 40 over 1 times pi over 180. So what happens here, let's do some canceling. I'm going to cancel my zeros. I'm going to cancel my 4 with my 9 and get, or my 18 and get 2 and 9. So 40 degrees is equal to 2 pi over 9 radians. Right here, our problem in radians to convert to degrees, I'm going to take 3 pi over 2 times 180 over pi. I am going to cancel my pi's. I'm going to cancel the 2 with the 180 and get 90. So I'm left with 3 times 90, which is 270 degrees. Why don't you guys try these right now? Stop tape. Okay, the first one, you should have written that out. We're going to cancel the zeros. I can cancel the 26 and the 18, divide each by 2. It looks like I get 13 and 9. So this then, the 260 degrees becomes 13 pi over 9 radians. And yes, the radians are often a fraction and in terms of pi. Okay? 11 pi over 4 radians. We're going to write those in degrees. We write the fraction first. Let's cancel my pi's. 4 and 180 can cancel to become 45. It looks like I have 11 times 45, which is 40 plus 45. 485. Is that right? 11 times 450, 495, sorry, 495 degrees. Next, let's talk about angles. An angle has two sides, the beginning side, or the initial side, and the ending side, or the terminal side. Okay? This angle right here, let's approximate it to be about 30 degrees. Its beginning side is always pointing due east. Okay, so here's the initial side, here's the terminal side. Okay, but another way to write this same angle, we're going to call that a coterminal angle. It's an angle that has the same beginning and ending sides. I can not only open the side clockwise, or counterclockwise, like I just did here to get 30. I can open it clockwise. If I open the angle this way, it is a coterminal angle, and this is going to open negative 330 degrees. I can also open the angle this way. And go all the way around the circle. So as you can see now, this angle right here, as I open, is 30. I go all the way around. There's 180. There's 360, and I add 30 more. This would be 390. So the same angle can be written as 30, negative 330, and 390. It can also be written, not that I'm going to do it, but I can open it up negatively and go around a whole bunch of times, etc. Alright? Why don't you guys look at this angle right now? I want you to convert it to radians, and then I want you to write two other coterminal angles. Okay, as we look right here, you should have written this much. I can cancel the 120 with the 180, pull the 60 out of each, so this becomes 3, and this becomes 2. So this angle is also equal to 2 pi over 3 radians. So this angle measured this way is 2 pi over 3 radians. I can also measure this angle the negative way. So I'm going to open it this way. That's going to be 1 pi when I get to here, and then I still have 1/3 of a pi to get to there. So I could also do that as 4 pi over 3, and that's negative. Okay? I can also measure this angle. Let's do this in black. I can measure all the way around. So here we go. I'm going to start opening. That's 2/3. That's 1 pi. That's 2 pi. 2 pi is a complete circle. And still I got to go 2 more pi. So that's 2 2/3 pi, which we always write as an improper fraction, 8 pi over 3 radians. All right, a couple things just to make your life easier. You probably just want to mesmerize these. These are degrees to angle, degrees to radians conversions. 30 degrees is pi over 6 because it's 1/6 of 180. This therefore is 2 pi over 6. This we just did is 4 pi. 2 pi over 6, which is pi over 3, my fault. Pi over 3. 120 we just said is double that, which is 2 pi over 3. And 150 is going to be 5 pi over 6. 180 is pi. Therefore, 90 is half of that, which is pi over 2. 45 is half of that, which is pi over 4. And 135 is 3/4 pi, so 3 pi over 4. and you probably just want to familiarize, if not memorize, those. Two formulas I'm going to give you, and then we are D-O-N-E. That is done in Spanish. The linear speed around a circle is how fast you're moving around the circle, so it's distance divided by time. Typically, our distance is going to be our S length. So we're going to write this as S over T, our arc length. Okay? The angular speed is going to be the angle, so that's theta, divided by time. There are two problems that we will do in class tomorrow, 111 and 113. We'll do those in class. Those are some linear and angular speed problems, and we'll see you tomorrow.